What's up, everyone? Welcome back. Patrick here, and moving on to the next few examples, we've got to simplify and state restrictions for these three expressions over here. So starting with number one, we got 4y over x to the power of 3 divided by 8y squared over x to the power of 2. So same steps are going to apply that we used when we were simplifying rational expressions. We're going to factor, state restrictions, and then simplify. So notice here with number one, we can't really factor anything because these are just single terms. Unlike these two examples that are coming up, we're going to be able to factor these because they're multiple term expressions. Here we can't really factor anything. So we could skip step number one and go into trying to find any sort of restrictions. So restrictions would be what values make the denominators equal to 0. So when does x cubed equal 0? In fact, x cubed cannot equal 0. And so when we isolate for the x, it means x cannot equal 0, right? We would take the third root of this side, third root of that side, we'd still end up with 0. So x cannot equal 0, that's one of the restrictions. And notice that that restriction is the same over here. X squared cannot equal 0. Now because we're dividing, we have to look at the numerator of this expression as well, right? Because if you're dividing, if the numerator is 0, it means this whole thing is going to be 0, and you can't divide by 0, right? So over here we're dividing by the x squared, but we're also dividing this whole expression, hence why we have to look for when the numerator would be 0. So it basically means 8y squared cannot equal 0. Divide by 8, square root both sides, it means y cannot equal 0. So those are the two restrictions right there. X cannot equal 0. Let's write it over here. And then y cannot equal 0. Those are the two restrictions for this expression here. And now that we got the restrictions, now we could simplify. So the way we're going to simplify this, first thing I'm going to do is I'm actually going to take this, I'm going to flip this, change it to multiplication, like that. Now from here you can do multiple things. You can simplify over here, like cross stuff out. When I'm dealing with single terms like this, I like to first personally multiply everything together. So if I multiply the numerators, I would end up with 4x squared y over 8x cubed y squared, like that. And then I like to simplify from here versus when I have expressions where I have like brackets, where I have actual larger factors, then potentially I like to cross out maybe at this point, just because it's easier to see what's going to cross out, versus here stuff can start getting a little bit more messy because things are a little bit more compact. But you can cross out here. So for example, the x squared over x3, you can cross out the x squared, you could cross out the 3, the 4 goes into the 8 twice, etc., etc. So you can simplify from here. I just find that when you're dealing with these kind of single terms, it makes the work a little bit more messy. So from here, notice that x squared goes into x cubed, so there's one x left over in the denominator. Over here there would be one y left in the denominator, and then 4 over 8 simplifies to 1 over 2. So we would end up having 1 up top, and then we would have 2 xy at the bottom. So that is the final answer right there. And then those are the restrictions. All right, so now moving on to number 2, exact same steps. So what we do, we first factor what we can. And notice here, there's going to be a lot of stuff that factors. This x squared minus 4, that's a difference of squares. That's x plus 2, x minus 2. This 6x plus 2, notice we could take out a 2 from that. So we would have 2, and then we would have 3x plus 1, like that. Divided by 2 minus x, that doesn't factor. And then 9x plus 3, notice we could take out a 3 from there. So we'd be left with 3x plus 1. Right, so we factored everything. Now what I'm going to do is get the restrictions. So notice that 3x plus 1, this factor cannot equal 0. which basically means x cannot equal negative 1 over 3. That's one factor. Notice that that same factor is here, but because we're dividing, we also have to look for when the numerator would be 0. Basically, this 2 minus x cannot equal 0, and when we isolate for x, it basically means x cannot equal 2. All right, and those are the two restrictions. We wouldn't look at this numerator here because we could take 0 and divide it by something, but we can't divide something by 0. And if we have an x value of 2, it would make this whole thing be 0. Can't divide by 0. All right, so those are the two restrictions. Let me write them over here. So x cannot equal negative 1 over 3, and then x cannot equal 2. And then from here, what we can do is go into simplifying. So I'm going to continue this over here. So we'll have x plus 2 times x minus 2 over 2, 3x plus 1. Now what I'm going to do is I'm going to flip this. So we would have multiplying 3, and then we'll have 3x plus 1. Divided by 2 minus x. Now, instead of writing 2 minus x, I'm actually going to take out a negative from that, and I'm going to change it to x minus 2. All right, if I take out a negative, it becomes x minus 2. And the reason why is because now the x minus 2's would cancel out. Notice if we bring back that negative inside the bracket, we would end up with 2 minus x, or negative x plus 2, which is the same as 2 minus x. And so from here, now that we did that, it's easy to see which factors cancel out. Notice the x minus 2's cancel out, the 3x plus 1's cancel out. And so the 3 over 2, that doesn't simplify, so we'd be left with what? 3 times x plus 2, negative 1 times 2, so that would be negative 2. And then this negative, let's just bring up top. I feel like it looks nicer that way. So that's the final answer. That's the final simplified expression with those restrictions. And then finally, number 3, we have this giant expression over here. So going to follow the exact same steps. First, I'm going to factor. So let's see if decomposition works for each of these. Let's see if they actually do factor. So starting with this one, we got 4x squared minus 8xy minus 5y squared. Decomposition, what do? Multiply these two numbers, so we'll have negative 20, and then we'll have that b value, negative 8. So what two numbers multiply to negative 20 and add up to negative 8? Well, negative 10 and positive 2 would work, right, in both cases. So what we do, we decompose this into negative 10xy plus 2xy like that, and then we'll have minus 5y squared. And then what we do, we factor by grouping. So notice that from these two, we could take out a 2x, so we'd be left with 2x minus 5y. Then over here, notice we could take out a y, and we'd be left with 2x minus 5y. Remember with decomposition, these two brackets should be the same. If they're not the same, something went wrong before. So now we could take out this 2x minus 5y, and then we would be left with a 2x plus y, right? Those terms right there. So this factors into that. So we'll have 2x minus 5y and then 2x plus y, like that. Now moving on to the denominator over here. So we have 2x squared plus 9xy plus 4y squared. So when we multiply these two, 8, middle term is 9. What two numbers multiply to 8, add up to 9? 8 and 1. So we could take this, decompose that middle term to 8xy plus 1. I'll just write a 1 there. 1xy plus 4y squared. From these two, we could take out a 2x, so we'd be left with x plus 4y. And then over here, we could take out a y, so we'd be left with x plus 4y as well. Then take out x plus 4y, and then we'd have 2x plus y, like that. So below here, this factors into x plus 4y, and then 2x plus y, like that. And then this numerator, we got 5x squared plus 21xy plus 4y squared. Multiply the ends, 20, middle term is 21. 20 and 1. Those are the two numbers. So we would have 5x squared plus 20xy plus 1xy plus 4y squared, like that. Then from these two, we could take out a 5x, so we'd have x plus 4y. And then from these two, we could take out a y, so we'd be left with x plus 4y as well. Take out the x plus 4y, and we got 5x plus y, like that. Right, so this factors into those terms. So we would have x plus 4y, and then we have 5x plus y, like that. You could always check these as well. You could FOIL them out, make sure you get those original expressions. And then finally, this denominator here, multiply the ends 10. What two numbers multiply to 10, add up to -7, -5, and -2. So we'd have 2x squared minus 5xy minus 2xy plus 5y squared. Right? Took this -7xy, decomposed it to those two. And then factor by grouping, take out an x. And then over here, we could take out a minus y. If this is negative, what you're going to factor out is always going to be a negative value. So this would be 2x minus 5y, like that. Take out the 2x minus 5y, and then we're left with an x minus y. So this here, we'd be left with 2x minus 5y, x minus y. Right, so lots of work on the side to factor. As you get more practice with factoring, a lot of times you'll just be able to come up with these brackets without doing all that work, but I want to show you all the steps just so you get comfortable with knowing the process, so it becomes really intuitive for you. So from here, we factored everything. What's the next step? Next step is get the restrictions. So in this case, notice that these factors here in the denominators, they can't be 0 because then it'll make the whole denominator 0 and you can't divide by 0. And notice in this case, because we're multiplying, we actually don't have to get restrictions from this numerator because this numerator in this case can be 0 because we'd be multiplying by 0 then. We can multiply by 0. Can't divide by 0, but we can multiply by 0. And then we could take 0 and divide it by a certain number. So we don't have to get the restrictions from here, but we do have to get the restrictions here and here. So basically, if we do that, notice that x plus 4y cannot equal 0. So you can pick whether to isolate for the x or isolate for the y. Either or works. I'm going to isolate for the x in this case. So notice that x cannot equal -4y. So that's a restriction. Then we have 2x plus y cannot equal 0. If I isolate for this x, basically x cannot equal -y over 2. Right? When I bring this over, divide by 2. 2x minus 5y cannot equal 0. So basically when I isolate for the x, x cannot equal 5y over 2. And then x minus y cannot equal 0. So basically x cannot equal y. Right? So those are the 4 restrictions for this. So you would write those in addition to the answer that we're about to get. And now you just simply look what can cancel out. So notice this and this cancel out, this and this cancel out, this and this cancel out. So we're just left with these two terms, right? Yeah, 5x plus y over x minus y. So that there is the final answer. That's the simplified expression. Those are the restrictions.